Hey everyone, welcome back. In this video, we'll continue talking about net present value, my favorite capital budgeting technique from chapter 10, and then also profitability index. We've got a brief mini exercise in this video, which I think you'll find pretty easy if you're keeping up with what's going on. So let's resume our discussion. And why don't we do some of these projects that are in these notes, and just to illustrate how they get done in Excel and to reinforce the notation and the syntax of the NPV function in Excel. Remember, the initial cash flow goes outside of the NPV function because Excel thinks that this first cash flow that you feed it in the range of the cash flows occurs at time 1. And so it'll discount the first cash flow in the range back 1 period and the second one back 2 periods and so on. So if you put the initial cash flow inside the function, it's going to assume that it occurs 1 period in the future. And that's not correct. So let's show how to do that with example 10-3. So here's the cash flows for that project. And to do it correctly, we say equals the first cash flow plus the NPV function. And remember the two arguments. The first argument is the discount rate, the firm's weighted average cost of capital, 10% in this case. And the second argument is the range of future cash flows. 41.32, there's a positive NPV project. That would increase firm value if we pursued it and if it went on as planned. Okay, let's do it with the next one, 10-4, right, equals the initial cash flow plus the NPV function. And then the first argument, discount rate. Second argument, the range of future cash flows. And then this project's NPV is negative. You can see that because the cash flow, it's essentially like $600 of cash flow moved from year 1 to year 2 if we're comparing the difference between project 3 and project 4 here, example 3 and example 4. And the timing of the cash flows clearly matters, right? Now this project's future cash flows are not worth the initial cost. So the mini exercise, if you think back a couple videos ago where you found this project's payback period, right? Let's establish a discount rate of, let's say 12%, right? So the mini exercise is, can you find this project's net present value using the correct syntax of the NPV function? I think you can. All right, thanks for working on that. And let's move on. So the key thing to understand, positive NPV projects are good for the firm, right? So let's find some positive NPV projects if we're managers, and then do not pursue negative NPV projects. This project 10-4, this example 10-4 is not a project that is not worth pursuing because it's not worth the cost. It's a negative NPV project. Okay. And so, we can use net present value to choose between projects. If we have to choose between two projects, if I could only choose one of these two projects, I would choose the one with the higher net present value because that would increase firm value more, create more value for shareholders. Right? If I could do both of these projects, I would, because they're both positive NPV and they both increase shareholder wealth. But if we have to choose between them, we want to choose the higher NPV project. Same goes with something like a real option where we have the option to delay, like if we have a tree farm, maybe a Christmas tree farm, right? And the game with Christmas tree farming is we could either harvest the trees this year or you could wait another year, trees get bigger and bigger trees can be sold for more money, right? So that's really what's going on in this little table. And the idea is, well, let's choose the option that creates the most NPV. And it looks like it's waiting 3 years in this case. Okay, because we have to choose among all these different options. We can't harvest the trees in year 0 and then also do it again in year 2 because the trees would be gone. So the investment timing decision, choose the option that maximizes net present value. Hopefully that's straightforward. And then one more capital budgeting technique in this video, profitability index, is kind of like a bang for your buck measure, and we'll illustrate how to compute it and interpret it. So let's see, here's this project from example 10-5. Here we go. We've got initial cost and future cash flows. We've got a discount rate. So if you found a project's net present value, then finding the profitability index is pretty straightforward. So a project's NPV, remember the first cash flow, plus the NPV function. First argument is the discount rate. The second argument is the range of future cash flows. This is a positive NPV project, okay? And so the profitability index is just the NPV divided by the absolute value of the initial cost, right? The absolute value of the cash flow at time zero. So that's 850. There's an absolute value function that you could put in if you want, but this project's profitability index is 0.0377. So that number in words means, right, this project generates, it's like a ratio. It generates 0.0377 of NPV for every $1 of, I'll call it initial cost, for every $1 you spend on it. Okay, just like interpreting a ratio the same way we did before. Project generates this much NPV for every $1 of the denominator. Remember that? So that's the profitability index. So this wraps up net present value and also profitability index. In the next video, we'll look at more capital budgeting techniques. Thanks for tuning in.